Right, okay. Welcome everyone to this session. My name's Steve Morgan. I'm a senior solution architect with a company called Starburst. You may or may not have heard of us. I'm going to tell you a little bit about who we are, what we do, and then specifically I'm going to talk to you about how we are used in highly regulated industries, so FSI, global banking, life sciences, central government, to help tackle data sovereignty and data governance issues and those kind of frameworks within our analytical data platforms, okay? So, a little bit of history first as to who we are, where we come from. So as a company, we were formed in 2018. We are a pre-IPO, VC-backed organization, company. We were founded by a team of engineers from Facebook, who in 2012 were tasked, whilst they were at Facebook, of fixing a challenge that Facebook had in terms of query performance, analytics performance on their data lake. Right? So by 2012, Facebook, who were running on open source Hadoop with the open source Hive engine, you may or may not be aware of, it was too slow. So the analysts were coming to them and saying, these queries are taking minutes or hours to run, or maybe even days. I'm having to schedule them over the weekend. They quite often fail. It's a real problem for us. So a team of engineers at Facebook basically sat down and said, we're going to replace the Hive engine. Facebook had invented the Hive engine back in 2008, but 4 years later, even though it was an open source and had been heavily contributed to, it was just not fast enough or powerful enough for the volume of data they had. So they built a brand new engine from scratch. That engine was open source. It was called Presto. I'll gloss over the shenanigans as to what happened from a legal and IP perspective point of view, but Trino is effectively that open source project. There is still the heavily popular open source Trino engine, massively scalable, runs on the highest volumes, highest concurrencies on your lakes, okay? That fixed problem number one at Facebook. The second problem was, the analysts came back to the team and said, this is great, my analytical queries now run in seconds or minutes, and that's brilliant. However, we have lots of data outside of the lake that never gets in. I've got useful analytical data in Oracle, in SQL Server, in Kafka message queues. I've got it all over the place. And whenever we go to the data engineering team to ask for that data to be brought into the lake, we are told that's a 6 to 9 month backlog to build the pipelines and the ETL processes, right? It's no good to us, what can you do to help? So the engineering team went back to this massively scalable, highly performant lake engine that they'd built, the Trino engine, and they expanded it into its second area of core capability. And that capability is to do live connections into data sources outside of the lake, or indeed to run without a lake at all across lots of different environments, right? That project, the open source Trino project, is so successful that the engineering team from Facebook, by 2018, they said, you know what guys, this engine is brilliant, but it's missing the enterprise features that we're also having to use here at Facebook, and that lots of commercial organizations using the Trino engine need. So things like query audit trails, who ran what when, you know, what client did it come in from, what IP address, security audit trails for your auditing guys when they come in, the ability to wrap data access permissions around all these data sources that you're exposing through the Trino engine, right? The fact that we can't pick up the phone, an open source Trino user can't pick up the phone and raise a support ticket when something's not working the way they want it to work. So the core team from Facebook, with some friends from Teradata, formed Starburst in 2018 to take that open source Trino engine and wrap those enterprise features around it. So we are still open source Trino at the heart of us. We still contribute to that project daily, but we have these enterprise features wrapped around it that most large commercial organizations need. Trino is the core engine, absolutely battle-hardened and proven at the biggest scales, right? LinkedIn, one of the biggest lakes in the world. I spent 5 years at Microsoft before joining Starburst. LinkedIn's data lake is over an exabyte in size. They don't use Microsoft technologies for querying that lake, they use open source Trino. It is absolutely battle-hardened. Admittedly, they're running on 1,200 machines, but that's because they've got such a big lake, right? We are a cluster-based technology. Lyft is an interesting example because we are a query engine. By that, I mean we run SQL. That SQL can be select, insert, update, delete, create, alter, drop, right? So Lyft users on both ends of their analytics platform. They use us to select from data sources and insert or update data in their lake. So they use us for ingestion because we do very high throughput, highly parallelized compute, highly parallelized disk I/O. That's how we get to massive scale. So they use us at the front end for ingestion and transformation, and then they also use us on the other side to be the analytical facing engine to run the select queries over those volumes of data. Right. We come in two flavors as a commercial offering. Starburst Galaxy is our SaaS version, turnkey solution, you never see the infrastructure, punch in your credit card details, you start connecting to your data sources, and you're up and running in a few minutes. We also have Starburst Enterprise. This absolutely sets us aside from the Snowflakes and the Databricks of the world. Starburst Enterprise is downloadable software that you run wherever you want. Starburst Enterprise can run on bare metal machines. We have customers, believe it or not, that run us on bare metal machines in their own data centers. It runs on VMs, it runs on Kubernetes. The VMs, Kubernetes could be on-prem or in the cloud. Right? Kubernetes could be your standalone version of Kubernetes, could be a managed Kubernetes service in AWS or Azure or GCP. So Starburst Enterprise runs anywhere, including completely air-gapped environments. Right? So let's have a quick look at it so you know what we're talking about. Okay, so this is the Starburst user interface. It's a web UI. Most end users do not see this, right? They can use it, and we do have customers that do it, and the permission settings on the screens means that if we do want end users, analysts to use this, they don't see all that stuff on the left-hand side, which is about managing the platform. They get a much cleaner looking interface. But this is kind of much of a muchness, right? For all of these platforms, I can see a bunch of admin type functions on the far left. I've then got a series of data sources that I can connect to, and then I've got a SQL editor here. Okay? We are an SQL engine, but we do this federation or virtualization to reach outside of the lake or to reach to lots of different heterogeneous environments. This instance of Starburst happens to be running on managed Kubernetes in AWS, but that's kind of irrelevant. These data sources that I can see on the left-hand side, these data sources here, those that are prefixed with AZ, those are actually data sources hosted in Azure. Remember, my Starburst deployment is running in AWS. I've got a bunch of other data sources registered with Starburst that are running in GCP, right? I get live direct access to all of these environments. These could be on-prem. From a demo point of view, we're only a 6-year-old company. We don't have any data centers, right? We run everything in the cloud. If I did have some databases set up on my laptop, I could connect to them. We don't care where your data sources are. We do hybrid querying. We can be deployed on-prem and run between data sources on-prem and the cloud. We could be running in the cloud, and we can stretch between, or we can reach between on-prem and the cloud and across clouds. Everything that you connect us to looks and feels like a SQL database. So for example, if I scroll down here, I've got a data source called Kafka, GCP Kafka. This is a Kafka message queue running in GCP. My Starburst is running in AWS, right? That was a live query that tripped across the wire to GCP, interrogated the Kafka message queue. I can open up the message queue. I can see that there's a topic. I can see there's a topic in here called customer, another topic called line item, et cetera, et cetera. This is live data. Every time I click this button, we're reaching across the wire to a different cloud, pulling this data back, right? Everything that I connect to looks and feels from a client application point of view as if it's a relational database table. SQL is the language that we talk. It's the most prevalent developer and query language in the world, right? Far more SQL developers than there are Java developers, as popular as it is. So everything that we expose and connect to looks and feels like a SQL table. Right? Your analysts only need to use SQL. If they want to use Python, we've got Python libraries so they can build data frames. All those Python libraries are doing is translating the Python into SQL and sending the SQL to the engine. Right? My Kafka message queue here has a topic called customers. I can run this query as if my Kafka message queue is a SQL table. Kafka doesn't talk SQL, it talks KQL. It's a horrible derivative language, right? But my end user now doesn't even care that it's a Kafka message queue. Because we are ANSI standard compliant, that's what we use, ANSI standard SQL, I can use any ANSI SQL function on this data. So all my windowing functions that I typically use with message queues, all available to me. All my aggregate functions, all available to me, right? Once I've got connectivity to these environments, I can take this to the next level, and I can join directly across them. So here you can see I've got a single SQL query. It happens to be doing some aggregation. Yeah. So I'm pulling different columns from different sources. I'm doing some aggregation on it. But the clever thing here is if you look at those sources, right? So the sources themselves, I've got a count table that lives in an Iceberg data lake table, right? I've got a customer table that lives in Oracle. I've got a product profile, lives in MongoDB, a document database. It doesn't speak SQL, but we do the translation, right? I've got a credit card payment that's hosted on SQL Server in Azure. Payments table here, hosting on BigQuery and GCP. And when I run this query in real time, having submitted that to the engine up in AWS, that's now reaching out across those 3 clouds, across those heterogeneous data sources. There's lots of clever things going on in the background in terms of push down, because we're very sensitive to network latency in this scenario. So if we can push stuff down to reduce the data that comes back over the wire, but ultimately we're getting 4 or 5 different result sets from 4 or 5 different environments, bringing it into our memory, stitching it together as if they were all local tables in the same database, and spitting it back to your client application, okay? So that's the power, right, of what we do. Let me go back to the slides. Okay. What we're doing in the AI space. Everybody's got to have an AI story, right? I wasn't going to talk about AI today, but I got told I had to mention it. So, from our point of view, we see Starburst as being a single point of access to your analytical data sources. Almost every company, I have spent 20 years in industry, didn't matter whether I was working in a global bank or whether I was working in a small charity, they all had multiple data warehouses and analytical platforms and data stores, right? Ultimately, when you're trying to do your global reporting or your board level reporting, you need to get all that data together. The previous approach was build ETL pipelines, right? Move the data into a corporate data warehouse, one place, centralize it, right? Problem with that is, 25 years ago, I'd go into a sponsor in a company and I'd say, if you want me to work on your project and build your data warehouse, telling you now, 75% of all your money and all your resources will go on building and maintaining ETL pipelines. You don't even know what they are as a business user, and you don't care, but they're absolutely critical to bring your data together. In our world, we don't have that ETL process. Yeah, we're stitching together in real time those analytical silos without having to copy and duplicate the data and all the engineering effort that goes along with that. Right? Because of that, you know, our ethos is that we want to be the single point of access to your siloed data. Now, in today's world, that means AI, right? So we're moving very quickly into the AI and the agentic, I almost stumbled over that word because I can't say it, agentic world here. So let's have a quick look at it. Let's have a look at what this means to us. If I can use Starburst as this massively scalable query engine, right, to do ingestion at the front end, because I can select at high speed from sources, and I can insert, update, delete, create, alter, drop into my data lake or some other repository or wherever I want, right? I can do all of that stuff at massive scale and high speed. I've then got my capability to not just run SQL queries over that, but we also have an embedded vector engine. A customer came to us and said, hey, one of our data silos happens to be Postgres Vector, PG Vector, which is a vector database, right? This is a kind of emerging technology. It's like, will you build us a connector for it? Because there's useful analytical data in there that we want to stitch together with everything else. And we did. And they then said, right, now we've got 4 other vector engines across the bank. Can you also build connectors for them? And we said, this is a problem for us, right? The vector technology landscape is very immature at the moment. We do not want to build 20 different connectors so that in 12 months' time we find out that 10 of them are redundant, right? So instead, we've embedded a vector engine within the Starburst platform. So you can generate vector embeddings, I'll show you them in a second, natively using Starburst, using SQL. Right? You can then insert, update, delete, delete's probably the but insert or update those vector embeddings directly into a native Iceberg table. right? We're not doing anything proprietary down here. We don't have a table format. We're not a Databricks that says, hey, we've got Delta Lake. We work with all the table formats in the lake. We believe in open architectures, right? So we store the vector embeddings in a native Iceberg data type. Right. Once I've got it in there, I can then connect into LLMs and my external AI models. Right? We do not run and host AI models, but we can connect to them and give you SQL access to the capability that they offer based upon your data, whether it's in your lake, whether it's on-prem or in the cloud. Right? So let's have a quick look at that in action. Let me just minimize this, and we've got a bit more space. So on the left-hand side, one of my admin screens, AI models. I've got connections here, established already or defined, to 4 different AI models. A couple of them are LLMs, a couple of them are vector embedding models. Right? When I look at these happen to be AWS public LLMs and models. Right? To us, this is just an endpoint. This could be an open source LLM that you're running on your own infrastructure. One of our other banking customers in the US, really interested in using LLMs, but highly worried about users sending sensitive information to a public LLM like ChatGPT, even under the corporate account. So instead, they use us with an on-prem hosted LLM, an open source LLM that they run on their own infrastructure. We don't care if this model is on-prem or in the cloud. It's just an endpoint to us, right? And when we make that connection, it then means that I can work with that model using SQL and just SQL. So if I go back to my query editor, I've got a very simple table here, right? Feedback table. Simple feature, some feedback on it. This is what I've gleaned or I've ingested from my Twitter-fed Kafka message queue, right? I'm streaming it into a table and storing it. But what I've now got is the ability to run SQL functions like this, analyze sentiment, right? As a SQL guy, and I don't do Java, I've never written Java, I can hack about with Python and some other scripting languages, I'm a SQL guy. This now means that I can invoke AI capabilities to run across my data in a highly familiar SQL environment, right? So I can run this query, and in real time, he said, sorry, that was because I double-clicked on the... And in real time, we've fed that column of information to this particular model. This function here is really just a wrapper around a prompt. So we've told the model that we want it to do a sentiment analysis on this data. So from an analytical point of view, I've now got some a sentiment analysis on this. I can persist this in a table and I can build reports on it. Or I could just use it in real time. Right? We have a library of AI functions now available to us. They're growing all the time. So some listed here, you won't be able to see many because of the size of the screen, but we've got a whole bunch of different things, right? So we've got, let me make that a bit bigger. It won't go any bigger. You can see in there classification, grammar fixing, we've got translation, we've got a whole bunch of other ones, and they all just look like SQL functions. Right? I've also got my vector embedding capability that I mentioned. So I have a table with book chapters in it to do with airplanes. And what I'm doing here is I'm pulling the chapter introduction from my table. You can see it here, I'm going to stand down here. So this is the column I'm feeding into this function, generate embedding, right? I'm telling it which model to use to generate the embedding. The output of that SQL function is this. So this vector embedding, this is a numerical representation of that text. Okay? Now I just generated that in real time. In reality, I would have put that inside an update statement, and I would now be persisting those embeddings inside a table, and I've already done that. Yep. So here's the full table. You can see I've got the chapter intros on the left, and the already generated and stored vector embeddings. Entirely native Iceberg data types. Nothing proprietary about that storage. Right? What that then means is that in my Starburst environment, I can start invoking vector functionality so that when I get a user prompt, it's hard-coded here. In reality, this would be dropped in from a client application. What chapter should I read to understand the balance weight of a Boeing 747? I wrap this inside the generate embedding function. In real time, I generate an embedding for this, and that then allows me to compare it using a similarity function to my already generated embeddings. So what I get back from this simple SQL query is a list of the best 5 matches in terms of chapters based upon my user question. Right? If you're doing anything with LLMs and RAG, this is the basis for RAG, because what Vector lets you do is to find related unstructured text and then attach that to the user prompt that then gets submitted to the LLM, right? I'm going to run out of time, I'm going to show you now, but we also have an LLM prompt function that would allow me to directly connect to the LLM, feed this question plus these 5 documents. So the LLM has an augmented prompt that is sent to it. Right? So let's go back to the slides. I'll skip over that one for time, brevity. Okay, so let's talk about governance, because that's why we're here, right? Starburst, a single connection from your client application, and we don't care what your client application is, as long as it's JDBC or ODBC connection, as long as it generates SQL, it connects to us, and we expose all those underlying data sources that we've registered with Starburst, right? If we then become a single point of access to all those silos, it means we're also ideally positioned to manage data governance. Yep. And this comes in several different forms. So for example, we have a built-in query log. Every query that comes from a client application, regardless of the client application, is recorded in our back end. So you can interrogate that. Not only can you see the SQL that was submitted and therefore the data that they access, you can see when they did it, who the user was that was logged in, what client application, what IP address, a whole bunch of metadata. And all of this information is just stored in our back-end database, which happens to be Postgres or Oracle. It's a database. I can connect my own dashboard to it. I can expose it through Starburst to do querying on it and analytics. Right? On top of that kind of audit trail and security audit trail, I've also got built-in access controls. Because again, if I'm sitting in the middle, then why manage permissions down here in lots of different places and duplication when I can do it once here? So back in my environment, I have got some roles, some security roles. Here's one I prepared earlier. So this security role has got access to any table in the Oracle data source, any table in the SQL Server data source. In my data lake here, it's got access to specific tables, and it's actually got some explicit denies. So anybody who's a member of this role, when their query hits Starburst, we're going to apply these permissions. I'm not setting any permissions on Oracle. Don't get me wrong, in the real world, and I was a DBA for a few years in my life, your Oracle DBAs are not going to stop applying permissions on the Oracle database. But the key thing here is from an analytical perspective, you are controlling who can access what. I can expose a huge amount of data through Starburst. I need to be able to control that access. And what that then looks like to your end user, if I use this client application here, so this is a client application called dbeaver. It's an open source SQL client. It's running as a fat client here on my desktop. It's connecting to my Starburst instance that we've just been seeing running up in AWS, right? I've got exactly the same SQL in both windows, except the first one is running under a sysadmin role. The second one is running under that demo role that I just created, right? So I run some of the same SQL queries. My sysadmin on the left says, give me a list of all the data sources. And he gets a big, long list of all of those data sources that we've registered with Starburst. The user on the right-hand side says, show me your data sources. He gets a restricted list. Can only connect to 4 of them. When my guy on the left says, tell me about rows in a table, give me a count of rows by country, my sysadmin sees that I'm split across 2 markets. My guy on the right-hand side is only allowed to see US data. All of this filtering and permissions is being applied at the Starburst level. No code changes in here. I don't care whether this is a Tableau, Power BI, dbeaver, Python notebook, makes no difference. We apply those permissions at the Starburst level. The data is pre-filtered. We also support data masking, column filtering, ABAC. We do the whole regime, and we're doing it at that central tier within the organization, within the platform. Okay. Okay, quick use case for you. I think you get a copy of all the slides afterwards. Some links here to the public press around this, right? So HSBC is a big customer of ours. We do a lot of work with HSBC on a global basis. They, like any big organization, have got lots of analytical data silos all over the place, right? Some of them are on-prem, some of them are in the cloud. Their great challenge was about staying compliant from a regulatory perspective while still bringing the data together so that they could do global reporting for functions like finance, risk, ESG, all of which are also, if contradictory, regulatory requirements, right? So in the old days, they used to bring data into these big silos. They knew that they were exposing themselves for risk on some of the regulations, right? So instead, what they do is they leave the data in the local market. We then sit as that virtual access layer over the top. The client applications, whatever they are, single connection to us, they then query those tables as if they're all local. But they're not. They're still in their original jurisdictions. Yeah, we are not a database. We don't have disks attached to our servers. We only read and write data to wherever you tell us to do it, right? So this is how HSBC have used us not only to unify their analytical platforms and to give a much simpler user interface to all these silos, but to also be compliant from a regulatory perspective. Okay. They're not the only ones, right? We work with all kinds of companies, big and small. Some of them are cloud only, some of them are on-prem, some of them are hybrid, right? We can deploy and run wherever you want. We run in highly sensitive air-gapped environments because we'll run on bare metal. We have plenty of customers that actually, believe it or not, run us on bare metal. And then they say things like, oh, we want to scale the cluster. It's like, well, you need to go and order a machine, right, and plug it in. If you're running on VM, Kubernetes, it'll auto-scale, right? So we run on the highly sensitive environments. 4 out of 5 top global banks work with us. We're big into FSIs. We're big into healthcare and sciences, telecoms, heavily regulated industries. We also work heavily with the technology firms, particularly around info security. So organizations that are sucking in huge amounts of telemetry, hundreds of thousands of messages a second that they need to dump to disk and analyze, right? As we work on those because of our scalability. But we work with all kinds of organizations. I won't go into pricing models, but we basically charge on a per core basis. So if you're only running on 4 cores, we're going to be very cheap if you've got small volumes of data, right? Okay, that's the end of today's session. However, I have got a minute or two. If there are any questions, I think I have to pop this on. Any questions from anyone? It's in both. So do you want me to say that? I've got the microphone. So the question there was, is the AI capabilities coming in our SaaS version or the on-prem version? I say on-prem, it runs anywhere. It's in both, is the short answer, right? Yep. Quick and sweet answer to that. It's one of those things that's rapidly developing. So everything I showed you today is public preview. It's due to go GA by Christmas. We're now working on MCP server for those of you who are in this space. So we'll have you can still use an external MCP server if you want, but we will have a built-in MCP server if you're looking to have a directory of agents that will automatically determine which agent should be used to answer a particular question. It's all about conversational analytics, right? That's the space that we're moving into. Any other questions?
Connecting to different silos databases, especially in banking and financial sector, wherein the data governance is the key, right?
Yep.
Do you see any challenges?
So the question was, were there any challenges around joining to these silos in different locations, different geographies, cloud, on-prem? The short answer is your InfoSec guys are going to be all over this, right? In reality, what happens is you're accessing that data already, but what you're probably doing is physically copying it to somewhere else. The InfoSec guys at all the big banking customers that we've got, for example, we're much happier with this as a solution because we don't persist to disk, we're an in-memory engine, everything is ephemeral when we've processed and returned the result set, unless you've got caching turned on, which is all off by default, that just disappears, okay? So the short answer is, yes, they had lots of questions, but when they realized we weren't duplicating data, InfoSec were happy. The budget holders were happy because they weren't paying for 2 lots of storage, right? So yeah. Got to call it to an end there. We're on the stand straight down from here on the left. Come and have a chat with me or any of my colleagues if it's anything I've said today is of interest. Thank you very much.